Hello everybody. This is Chapter 1 of our Business Statistics course. This will be an overview of statistics and data. And what we're trying to cover in this chapter is really the importance of statistics that we have in our class and in society, how we're going to look at the difference between what we call our descriptive, those that kind of tell a story in statistics, and those that are inferential. Inferential meaning that we're going to be able to take a sample from a population, we'll get into that, and draw a statistic which comes from the sample that tries to tell a story about the population at large. We're going to look at the need for sampling and how there's different types of data out there, and then talk about variables, why they vary, and the types of scales that we play with. Now, to introduce this, and this is a pretty simple one, we'll look at some tweens, young kids, and answering some questions, such as which radio station was playing on their drive to a particular place, like a ski resort. Rate the quality of food on a Likert-based scale, 1 to 4, 1 meaning really like, 4 meaning really don't like, or vice versa. It just is a scale. What time should the main dining area close? An exact time. And how much of your own money did you spend while you're traveling? Now, here is a collection of some of their responses, and I'll be putting some of this data out there for you to look at, but if you look at it, you'll see that from the questions, which radio station, here we can see in this area looking down column Q1, we have a wrap here as well. There's the stations. We see that we've got multiple Jammin 94.5. We also see that from this, we can find the quality of food 1 to 4, the times that they had that the main dining area should close. Maybe they liked or didn't like it. That's an additional question. And how much of your own money did you spend? And you can see that here in question 4. It's not listed as dollars, but there's an implication of dollars, and they seem to be at $5 increments. With this, we want to classify their responses by their appropriate measurement scale. We'll get to that. But is it a quality or is it a quantity? What information can we extract that's useful and helpful for us and actually is of importance? And then how do we provide management with suggestions for improvement as we look at this resort and on the transportation to the resort? So let's just talk about statistics. We'll get back to that case here in a minute. What is statistics and how do we get to the knowledge of statistics? Well, statistics is very important in what we do in our daily lives. It's with this knowledge of statistics, we can really avoid making many uninformed decisions. And those decisions can be very costly if we're not aware of the available information behind it. It also allows us to differentiate between sound conclusions, which are statistical, and questionable conclusions, which often aren't based on statistics, which are just simply based on hunches. So, for example, we read something from a newspaper. It says, "What global warming?" After we see record snowfalls in 2010. That's an interesting example. What we're drawing a conclusion based off of one data point, 2010. Maybe not. We've had some global warming based on the amount of snowfall. But in this one case where we had a lot of snowfall, record amount in 2010, we can't draw the absolute conclusion that there is no such thing as global warming. Maybe, may not be, but we're just looking at one example here. Maybe we should look at a run of data, say from 1900 through 2016. A gambler predicts that he'll roll a 7 on his next roll of the dice since he was unsuccessful in the last 3 rolls. 7's interesting because it is by far the most that shows up on a pair of dice. You've got 1, 6, 6, 1, 3, 4, 4, 3, 5, 2, 2, 5. So you have 1/6 of all the rolls could be a 7, but the probability of rolling anything on 2 dice is constant. It has no memory, so there's no such thing as a hot streak. It's just rules of probability. It's what's happened is someone has been beating the odds. When we look at something like a Boston Globe poll, 15-point lead from Martha Coakley, this was pretty famous a number of years ago. It said that she was going to easily beat Scott Brown. Turns around 9 days later, Scott Brown wins. The prediction was based on old information and wasn't updated with the most people who were likely to vote. Maybe it was based on those who were unlikely to vote but just had an opinion. All these things get you the idea that you've had the right statistic at the right time would help make a better informed decision. CFO of Starbucks says the business is picking up since sales at stores opened last year climbed 4% in the quarter ended of 2009. Well, he overstated the company's financial position essentially by failing to mention that they closed 800 stores over the past year, saying that hey, maybe that is just because they're forcing people to move into other stores simply because there wasn't availability of some stores in the first place. So these new stores add inflows of customers from stores that closed. And a few others, researchers show that infants who sleep with a nightlight are much more likely to develop myopia. This is the correlation causation. We don't really know, but we do find this to be the case. So we would continue to do studies to see if there really is an effect where if we do one thing, for example, use a nightlight. So it isn't cause and effect to this. Really what it is there isn't a causation. There's a correlation. It's a linear style association, and we'll spend more time with this as we move through statistics. So what is statistics? It's really a methodology of extracting information from data. And to do great analysis, you have to do and have good data. Now, statistics is also part of what we see here. A statistic is drawn from a sample, as we'll see. And if we didn't actually draw from a sample, we just drew from populations that greater and larger size. This class would call parameters. But for now, we'll think of statistics as a way of gaining information from data to make better informed decisions. You have to have the right data, and you have to know what tools to use at the right time. If you can have those two things and communicate it very well, you'll be very important, because the power of statistics comes from the communication of those that can do the statistics to those that need the statistics to make the decisions. Two kinds of statistics, as we'll see. There's descriptive. That's what kind of paints the picture without telling the story of what's next. And inferential statistics that draws the conclusions based on samples. So the descriptive statistics is often left up to the reader to decide based on a presentation of data, typically charts, graphs, things like that are trying to tell a story through presentation. And inferential statistics, where you actually draw the sample, go through the process, and come to a conclusion. The inferential side is very common. But I've talked about population quite a bit so far. The population is the over-encompassing group of data. A sample is a subset of that. For example, we run a U.S. census every so often in the United States. That census is essentially all people living in the United States that can be counted. A sample of that might be I pick randomly 100 people from each state, hoping that the sample is a good representation of the population. We take samples because drawing from populations can be exhaustive, but sampling, when done right in the right manner, actually does replicate the population quite well, and we can test for it statistically. So population is all sets and all items of interest, samples the subset. The statistic is calculated from the sample, and the parameter is what we calculate from the population. We hope the statistic mimics the parameter when drawn. Sampling. Why do we sample, and what's the point? Well, as I said, it's exhaustive and it's expensive to get all the information for a population. So what we want to do, because of the impossibility of often gathering information from a population, because it's an unending population, is that we'll take a subset. The types of data that we would draw from to get the subset from the population, one is cross-sectional. It's kind of a snapshot in time. Collect the data at a particular time about something. Surveys could be that way. We look at groups of people within sections. That cross-sectional or snapshot data is very, very common. The other type is a time series, where we let things play out in trends, so we can look at things over periods of time, daily, weekly, monthly, quarterly, and so on. You can watch things and see trending. For example, here's the US GDP. You might even see that if we imposed a line, we might even see it growing southward, downward, from 1980 through 2010 as we see growth. And as we move on here, we've talked about the kind we draw, time series data, which isn't nearly as common in what we do as the cross-section or snapshot. It's the scales and the variability, the variables themselves that we measure, that are so important. Variable, we'll talk about that a lot. Simply that, it varies. It's the thing of interest, the general characteristic of interest for us that we're observing. And there's two types. There's the qualitative type of variable, the qualities that we paint to something, and the quantities, those numeric values that we can do mathematics on. And those can be both discrete, countable or countably infinite, and continuous. So from the quantitative side, the discrete, again, they're countable, and they can be countably infinite, but we're seeing that number that I can actually count the number as we go on. Continuous assumes that we have, over time, an infinite number of values that you could essentially draw as many possible values between 2 points. Weight, height, if your weight can be measured in pounds and then ounces, and you can keep the decimals running out as far as you want to go. Same with height. Investment returns can go on into infinities on the decimal side. So if it has an unending value, it's a quantity. So there's quantities, and then there's qualities. We just talked about the quantities. There's interval and ratio type, and there's qualities, nominal and ordinal type. And the nominal and ordinal type, as we'll see, are the ones that contain the least amount of information, and the interval and ratio contain the most because they're quantitative. But as you look down the scale, each one that comes after here, as we see, subsequent to the first, has all the information, as we'll see here. So everything that's an ordinal comes from nominal. So all nominals in ordinal, all ordinals in interval, all intervals in ratio. The nominal scale is in name only, by far the least sophisticated. We can't do much with it except count them. Most can. So we'll count up the exchanges here. Is it NYSE or NASDAQ? Simply put into groups and count it. Ordinal means that you can put them into groups, you can count them, but the order is important, but we still can't do any kind of rank. Now, back to the nominal side, you can have nominal values 0, 1 that just simply represent a quality, count them up. Or what we can do with ordinal is rank them with some respect to characteristic or trait. Not a big deal, but it is one step above. It takes everything in nominal, where we would take things and put them in groups and count them, but now the order is important. Freshman, sophomore, junior, senior is a very common way of thinking something on an ordinal scale. We know the order is important. Then the tween survey, if we looked at these different scales of measurement here for the quality of one, the radio station, there's no order of importance here, so these would be nominal. But for the ranking scale, what you thought of the quality of food, 1 being really bad or 4 being really good, they're just qualities represent 1 being really bad, 2 being somewhat bad, 3 being somewhat good, and 4 being really good. They represent qualities, but the order is important. The other two, time and the amount of money you spend, those represent something completely different. Those represent quantities. The quantities, quantitative data, we have the interval and we have the ratio scales. Interval is the least used of all three, but it does still contain the values that we just saw in interval, where we have order of importance and things can be ranked or counted if we wanted to, but now we're beginning to do math. The interval scale is a quantity, but it doesn't have an absolute 0, meaning there is no specific starting point. It's very uncommon. We often talk about things like shoe size, scales of temperature that are non-Kelvin. We talk about ranking that way. So we often see interval coming from these types of things. Here's one of these. So these are very rare. Trying to figure out with ratioing an increase from 40 degrees one day to 80 the next. Did the temperature go up twice as much, or is it 40 degrees warmer? Well, it depends what the starting point is. There's no true 0 to tell us what a 2 times increase in temperature means. Is it from 1 degree to 2 degrees or 40 to 80? They're both up times 2. The ratio scale, by far the most common, contains everything in interval, which means it contains everything in nominal and ordinal. Strongest level, the one we want, you can do everything you want, and there is an absolute 0. 0 means this, it's where you start. Ratio scales are everywhere. We can count, but we can also see them as a measure of doing all measures of mathematics on them. So as we look at what we've seen, how they're classified, if we look at the time can be, a specific time can be thought of as an interval scale, because the time can be brought out to as many degrees as you possibly want, versus the amount you spent on food, Q4. This is back from that tween survey, that is actually an interval. So if I spent $5, the next person spent $10, they spent $5 more, which is also twice as much. We also know that you can start with $0 and have $0 spent. So if you look back on everything, what can you draw from this? Not a lot. This kind of introduction to statistics, when we look at how we project data, doesn't tell us much, but things you can learn. 60% of the students listen to K108, since we know that's nominal, we can look at these here. That means that quite a few are listening to that. We know that 55% felt the food was, fair. So that means that whatever we're scaling this on, 1, 2. So let's just say 55% thought it was probably 3 or 4. 95% would like the dining area to remain open later. That would be great for tweens. And you can learn a lot of other things. 85% spent their own money at the lodge, but we could also do more with this since the amount of money you spent is ratio. We could also look at it as certain amounts spent proportionally this much more or this much less than another. That wraps up chapter 1. We'll be moving on to chapter 2. And all throughout this entire sequence, the intention is to get us to the idea of regression. Everything we do builds on this. Understand this makes this next step that much easier.